Okay, in this video, we're going to go ahead and explore the inverse properties that we just learned in the previous videos and apply them to this business of the exponential and logarithmic inverse relation, especially when we're looking at graphing here, okay? So the first things first is that what I want to do is that I want to take a look at this column here, and this is a graph, okay, of that function below. But I want to get some numbers on here. So basically I want to plug in each one of these. So I'm going to get like 2 to the negative 2 power, which is going to give me 1/4 if we remember what the exponential properties are of negative numbers, and 2 to the negative 1 power, which is going to give me 1/2, 2 to the 0 power, which is going to give me 1, and then going right down the line here, using our properties of exponents, finish this up just like so. All right, now here's where all the points appear on the graph. Okay, so what we're going to go ahead and do is that we're going to be doing a just kind of like a quick analysis of showing that these are inverses of one another. So anytime that you have those two that are going to have the base, okay, these bases that are the same, okay, are going to be inverses of one another when one is exponential and one's logarithmic, okay? So something important to remember when we're starting to navigate through these is that, of course, these are all the x values to start off with, and these are the y values, okay? So these are the y values here. Now, if these are true inverses of one another, we know that the x and y's switch places. So for the log, okay, what we're going to do is that we end up with something a little bit interesting. So let's take a look. Okay, so to demonstrate that they are going to be the inverses, or using the inverse property here where x and y's switch place, notice that here is the y, but I'm going to plug it in for x in this column, okay? And to solve for y, I'm just going to solve the first one out just to show you using the definition of a log, okay? So I'll put y here for the time being. And we know that we got 2 raised to some power equals 1/4. And we practiced this before. So we got 2 to the y equals 1/4. I can write the right-hand side, or rewrite it as 1/4 is going to be 2 to the negative 2 power. And then since the bases are equal, I can equate these, and that is going to give me y is a negative 2. Okay, and that works throughout all of these guys right here. So backing up and demonstrating what we have in the relationship is this. When we plug in the y value, okay, to the x value here, we're going to go ahead for the y value, get that x value out. So the x and y's switch places all the way down. So that would mean is that, continuing with this pattern here, is that if I were to go to the next one and say the log base 2 of 1/2, that's going to give me, notice that this got put in here. All right, let me do that in a different color so it's this got put in here, and therefore that's going to equal a negative 1, which I know was the input. Okay, so I'm going to fill out the rest of this, and we'll be right back. Okay, and so that's what that's going to look like. Again, the pattern still holds in place. And when I graph these out, graphing this, I know that all of these will be the x values, and all of these will be the y values. So let me plot them on the graph above. And there is the graph of this guy now. So this one, and that is the graph of that. Okay. Notice that we have the inverse relation of, it is reflecting over the y equals x axis like this. Okay. And that is going to go ahead and be how we're, just basically, I don't want to say derive, but show that not only are they inverses, but where the logarithmic graphs come from. So let's tackle this e to the x part next. Okay, so plugging in all the x's for e to the x, you notice that we get some pretty yucky numbers, and we know that e is irrational, which basically means is that if I'm going to plug in a number for x in this equation here, other than 0, it's going to have a number that's going to be a long line of non-repeating, never-ending decimals. Okay, so I just grabbed the first 2 decimal places so we can estimate them out on our graph. Now, to show that these are going to be the inverses of one another, so let's flip these back around, and this is going to hold true for these guys then. Okay, so as I plug in this y value in for this, so if I go ln of, and this is just an estimate, okay? It's not going to come out exactly the same because I would have to plug in an infinite amount of digits, but it's the only way that we can really take a look at the actual points to get them on the graph without, getting in a calculator and all that other stuff. So, at any rate, notice that as that y value goes in there, the x value of this guy comes out. So the x's and y's all switch places. So I'm going to fill in the rest of that. Okay, and looks like we have the inverse relationship going there. And what I'm going to do now is put them, we already have e to the x down below, and now we have the inverse, which is the natural log of x, where this is going to be, as we saw in earlier videos, a base of e there. Okay, so again, the bases, if telltale of an inverse is that that's going to be that base of the log. Okay, so the base of the exponent is the base of the log in the inverse. And so I'm going to plot all these x values, and the y values are going to be coming out right here. So let me put them on the graph above. Okay, and you can see that I quickly ran out of room as these last bits right here, these 2 guys started to go off the graph very quickly, just as the y values in the exponential did. Okay, so there we go. And notice once more is that it has the reflection of one another through the y equals x-axis, which is telltale of inverses. And this is basically where they come from, okay? And I wanted to give you that background before we start actually graphing out logarithmic functions in the next slides. And so that's where they come from. Do we need this information to graph all the logarithmic functions coming up? No, we don't need to do this pound for pound, but it is good information. We're going to do a parent function, just like the other stuff, which is going to be these guys right here, and then we'll see where that takes us. Okay, so that's that, and I'll see you in the next video.